Welcome to Built, Wired, and Secured. I'm Alex Morgan. In today's episode, we're discussing airflow and airwaves, segmenting HVAC and OT to keep buildings running, what it is, why it matters, and what decision makers need to know to avoid costly mistakes. Joining me today is Michael Harrington as we break down real-world lessons, common challenges, and practical takeaways you can apply immediately. Let's dive in.
Cold open. Imagine a mid-rise office building on a busy Monday. A firmware update on a rooftop air handler causes repeated reboots on the building management controller. Within an hour, climate controls for 2 floors fluctuate wildly. Several tenant spaces lose internet as a shared switch hits high CPU. The lobby doors get stuck because access control relies on the same network. Tenants are calling the front desk. Maintenance vendors are on site trying to figure out ownership, while people complain and productivity drops. That's the kind of cascade we're talking about today.
Why this matters. When HVAC and other operational technology share infrastructure with IT or tenant services, the risks go beyond security jargon. Downtime becomes a tenant, safety, and revenue problem. Today, we'll unpack the root causes, trade-offs in segmentation approaches, practical architecture patterns, and real examples, so you can make better procurement and operational decisions.
Thanks, Alex. To start, what breaks if this goes down is the question I ask on every project. Root causes are usually pragmatic. Someone needed connectivity quickly. The path of least resistance was to put the BMS on an existing switch or run controls over tenant cabling. And vendor scope often ends at make it work, without clear demarcation. That convenience creates single points of failure and muddy responsibility after handover. From an operational standpoint, when ownership is unclear, issues take longer to resolve and costs climb.
Can you walk us through the common pathways that get OT onto shared networks? Are these mistakes, shortcuts, or a mix of both?
It's a mix. Common patterns. Contractors piggybacking on tenant or IT switches to avoid running new cabling. Building owners asking for just get it online to meet move-in deadlines. And integrators using remote access over the corporate internet for convenience. Each of those reduces upfront cost or schedule friction, but they create coupling. That coupling is fine until it fails, and then the downstream impact is visible in tenant complaints, emergency repairs, and strained vendor relationships.
Let's talk trade-offs. Strict isolation sounds safe, but it can be costly or hard to manage. Managed connectivity sounds flexible, but can it preserve resilience and accountability?
Trade-offs come down to 3 practical axes: uptime, manageability, and vendor access. Isolation, physically separate networks or dedicated switches, maximizes uptime isolation and simplifies root cause analysis, but it raises capital and operational overhead. Managed connectivity, segmentation via VLANs, firewalls, or air-gapped management paths with controlled cross-connects, lets you share infrastructure and reduce cost, but it requires disciplined change control, monitoring, and a clear service demarcation. The right choice depends on risk tolerance, contractual clarity, and how critical the systems are to occupants.
From an operational standpoint, what are the must-haves if teams choose managed connectivity?
If you're not doing full physical isolation, you must have role-based access controls for vendor accounts, centralized logging and monitoring that alerts on anomalies across OT and IT, a documented change control process tying vendor changes to maintenance windows, and clear escalation paths. Also, test failover and recovery plans. That monitoring is what tells you whether segmentation is actually working in practice, not just on paper. Without those operational controls, segmentation becomes theater.
Let's get concrete. What architecture patterns reliably reduce risk without adding untenable complexity?
3 pragmatic patterns we use. 1. Logical segmentation with enforced boundaries. VLANs plus firewall rules and ACLs that explicitly limit east-west traffic, paired with tenant isolation for multi-tenant sites. 2. Physical separation for critical systems, separate conduits, separate vertical risers, or dedicated switches for life safety or critical care HVAC. 3. Clear service demarcations and handover documentation. labeling, a responsibility matrix that lives in the O&M manual, and accepted test procedures before closeout. Those steps limit blast radius and make troubleshooting deterministic.
How should teams handle vendor remote access? That's where many headaches show up.
Prefer brokered remote access, jump boxes, or vendor portals that provide time-limited, logged sessions over static VPNs or shared credentials. Require multi-factor authentication and documented approval for each session. Crucially, make remote access part of the contract and handover. Who configures it, who pays, and who audits logs. That stops "that vendor did something" from becoming a finger-pointing free-for-all. Tenants feel this immediately when services fail, so accountability matters.
2 short examples. First, a multi-tenant office where the BMS sat on the landlord network. A software update overwhelmed a shared switch and took down tenant internet on 2 floors during a lease renewal week. The fix: we created a dedicated BMS VLAN with enforced ACLs, moved BMS management ports to a separate management plane, and updated the vendor scope. Recovery time dropped dramatically, and disputes stopped.
Second, a regional healthcare campus that prioritized separation during renovations. They invested in separate conduits and a second riser for OT. It cost more upfront, but during a later network refresh, the operations team was able to work in parallel with IT and clinical teams without risking clinical HVAC or critical environment stability. That upfront clarity paid for itself by avoiding costly downtime and scheduling conflicts.
Those are useful contrasts. Before we close, give listeners 3 clear decisions they can take today when scoping, procuring, or operating HVAC and OT systems.
Decision 1. Define the service demarcation up front. Specify who owns cabling, switches, and access controls in the contract and the O&M manual. Decision 2. Require monitored segmentation. Whether VLANs or physical separation, add logging and alerting to verify isolation in practice. Decision 3. Make remote access accountable. Use brokered access, MFA, and require session logging and periodic audits tied to vendor scope and payments.
Key takeaway: pragmatic segmentation combined with clear contracts and operational controls reduces downtime, clarifies ownership, and keeps tenants and occupants productive. Small architectural changes plus disciplined handover are often far cheaper than repeated emergency fixes.
Visit our website for a downloadable checklist and sample scope language to use in RFPs and contracts. Everything we discussed is captured there, so you can act on it immediately. That wraps up this episode of Built, Wired, and Secured. Today we explored pragmatic segmentation of HVAC and OT to reduce outages and clarify ownership, and why those choices matter to the people responsible for planning, operating, and protecting technology environments. Thanks for spending a few minutes with us. Until next time, make sure the systems you're responsible for are built to last, wired with intention, and secured for the real world.